We learned yesterday in 7.3 and what we're going to be adding on to today is this one word, and that word is regular. And when I describe a polygon as being regular, I'm telling you it's two things. I'm telling you first that it's equilateral and that it's equiangular. Who can raise their hand and tell me what equilateral means? Marissa. Good. All sides. All sides congruent. And equiangular means? Alex? Perfect. So with one word, I have now told you two things. That this polygon is, if it's regular, its sides and its angles are congruent. Now, yesterday we learned, and Friday I believe, we learned formulas that relate the number of sides to like the sum of the interior angles, or really just the sum of all the exterior angles, right? So I want you to think about that and try to generate an answer for this question right here. The measure E of each exterior angle of an equiangular polygon of n sides is given by the formula what? What do the exterior angles have to add up to? Yes?
360.
The exterior angles have to add up to 360. Now, if this polygon is equiangular, that means that all the exterior angles are the same. So what could you do to 360 to get the measure of each one? Jazzy?
Divide by 4.
Divide by 4 if n was 4. But so what if I didn't know the number of sides? What would I divide by? N. Perfect. So here's your formula. 360 over n is equal to the measure of each exterior angle. This is one you definitely want to know, so put a star by it. So now we can use that to do number 1, in which we want to find the number of degrees in each exterior angle of an equiangular pentagon. So the first thing you should think is what the value of n would be for a pentagon. Yes, Alex? 5. So write n equals 5. And we just learned the formula, which is that 360 over n is how you find the measure of each exterior angle. So I'm going to replace n with a 5. 360 over 5. Do some quick division. Yes?
The answer is 72.
Good. So 72 degrees would be the measure of each, write this down, exterior angle. Now I want you to think about the relationship between an interior angle and an exterior angle. So what I'm going to have you do is to draw a pentagon. Draw a pentagon, and we just found that its exterior angle here was 72 degrees. So label the exterior angle. And how could we use the fact that, well, rather, let's think about the relationship between an interior angle and an exterior angle. Andrew, what do you think the relationship is?
They are sub.
I agree, they're supplementary. So how could you use that then to find the measure of the interior angle?
You can do 180
Perfect. In other words, 180 minus the exterior angle equals the interior angle. Or in this case, it would be 180 minus 72 to get our interior angle as 108. So in this problem, although it only asks for the exterior angle, I ended up finding the interior angle as well. So this would be each interior. And it's important not to get these mixed up, so make sure you're good about labeling them, okay? Now we're going to kind of repeat that number 2, but before we do it, will everybody cross off the word heptagon? And I actually just want to find it for a hexagon, because a heptagon gets us into some fractions, and I know you guys can handle it, but it'd be easier for my purposes right now just to make it a little simpler. So let's recap on number 1. What did we do first? Marissa?
We found the exterior angle.
We found the measure of the exterior angle. So number 2 says use the exterior angle formula to help calculate the measure of an interior angle of a hexagon. So in number 1, we started by finding the exterior. So what's the exterior angle for a hexagon, or how would I find it? Alex?
360 over 6.
Good. So then that would give us that each exterior angle would be 60 degrees. Now what do I do to that 60 to find the interior angle? Casey?
Subtract it from 180.
Subtract it from 180. Giving us our interior angle to be 120 degrees. Perfect. Now, what we learned before was that to find the sum would be to take the n minus 2 times 180, and that gives us the sum of the interiors. Well, if you knew the sum, couldn't you just divide it by the number of sides, which is the same as the number of angles? You could do that as well. N minus 2 times 180 all over n will also give you each interior angle. However, this formula is a little harder. So I suggest instead using the formula that we're going to write down in number 3, which says to write a general formula for finding the measure of an interior angle of an equiangular polygon using the exterior angle formula. Marissa, what do you think?
180 minus and then parentheses. 360 over n.
Good. You actually don't even need the parentheses. You just go 360 over n. Perfect. That's the measure of each interior angle. Make sure you have that down on your paper, and then we're going to put some stars by it. All right. So now let's use these formulas, and we can see how we would use it on a test. In number 4, if an exterior angle of a regular polygon has a measure of 30, how many sides does it have? It wants us to work backwards. So use the exterior angle formula, which is 360 over n. But now we're going to set it equal to 30 degrees. This looks like a proportion to me, so the way I would solve it would be to put a 1 under the 30 and to think cross-multiplying. It's actually a little easier than this, but this is the way I always approach it. So if I cross-multiply, I would get 30 times n is equal to 360 degrees. Divide out the 30. Cross off the zeros. 36 over 3. 12. So the answer here is 12 sides. What's the name of this polygon? Dodecagon, but yes. That was very nice. Now, number 5 is exactly the same, except it says if the exterior angle has a measure of 50, how many sides does it have? So who can help me set up number 5? If it's almost exactly the same. Chloe.
360 over n equals 50.
Perfect. So once again, I'm going to put a 1 under the 50 and think cross-multiplying. 50n would equal 360. Divide out the 50. Ah, very good. 7 and a fifth. That would be our value of n. But let's take a step back. This n is supposed to represent a number of sides. Can we have 7 and 1/5 sides? No. So really your answer would be not possible, because you must have a whole number of sides. Number 6, put a big star by it, because this one is probably one of the tougher ones that you'll have on your test this week. If an interior angle has a measure of 144, how many sides does a polygon have? So you're working backwards, but you're going to be working backwards with the interior angle formula, which we decided was 180 minus 360 over n. So that means this has to be equal to 144. Once we solve this algebra problem, we'll have our answer, but it becomes tricky of how we want to solve it. I like to keep things positive, so I'm going to subtract the 144 and then put the 360 over n on the other side. So if I subtract 144 from 180, I get 36. Put add the 360 over n to the other side. And now this becomes just like one of the problems we've been doing the last 2 problems. Slap a 1 under the 36 and cross multiply. Divide out the 36. Very good. I heard the answer, and it's 10. Byron, what's the name of this figure if it has 10 sides?
Decagon.
Good. Remember that you need to memorize the names of the figures. Okay, one last problem together. Number 7, the ratio of an interior angle of an exterior angle is 3:2. Find the name of the polygon. So, without thinking about the ratio, what's the relationship between an interior angle and an exterior angle? Yes, Alex. They're supplementary. So let's draw two supplementary angles. Let's make this one the exterior angle. Let's make this one the interior angle. For most polygons, the exterior angle is always smaller. It's equal in a quadrilateral, and it's actually bigger in a triangle. But other than that, they're always smaller. So, and I know the relationship of inside to outside would be 3:2. So remember, we remember to set it up like that when you see problems that say find the ratio of 3x to 2x, and we know they're supplementary. So who can write an equation for me that would relate those? Yes.
3x plus 2x equals 180.
Perfect. Write that equation. Simplify. Divide by 5. 36. Good. Now, we're not finished because it didn't say find x, it said find the name of the polygon. So we have to do a little more investigating. So what would be helpful for us to know to find the name of the polygon? We need the number of
Sides.
sides. So how can we use this 36 to find the number of sides? Well, might it be helpful to know maybe the exterior angle? So let's plug it in here. And therefore, 2 times 36 would give us an exterior angle of 72. Okay, well, if 360 over the number of sides is equal to an exterior angle, then in this problem, 360 over n would have to equal 72. If we have the number of sides, then it would be easier to find the name of it, right? Put a 1 under it, cross multiply. Divide each side by 72. We've actually done this math like 3 times on this page, believe it or not, in some form or another. But if you don't remember, let's try dividing by 6. If I divide 360 by 6, that's like saying 36 divided by 6 is 6, add a 0. If I divide 72 by 6, I get, oh
9.
man, ooh, more like 12. So now 60 over 12, we all should all know our 12s, right? If not, we can divide by 2, but yes, this is 5. So Andrew, if we have 5 sides, what do we call this figure?
Pentagon.
Thank you, Pentagon.